All right, here's a more advanced question involving SOHCAHTOA or right triangle trigonometry. We're going to walk through this question together, and then I'm going to preview with you some more advanced questions that you'll see in the very near future. Once you pause the video and get a good look at this question, read it from start to finish. Read it a couple times, and then we're going to start it together step by step. All right, now that you've read the video, more than once I hope, we're looking for how fast the speed that the climber is climbing in, and the speed we're looking for is in feet per minute. So we need to figure out how many feet the climber is climbing within the time that we're told. Well, one of those boxes is very easy to figure out. They're traveling in 1 hour. So 1 hour would be 60 minutes. So how many feet they're actually traveling, though, will take a little while to figure out. Now, to turn the distance and the time into a speed, we're going to divide. The word per in math means to divide. For example, 38% means 38 out of 100, or 38 divided by 100. So we're going to have to find out how many feet the climbers climbed in that hour. All right, and to do that, we're going to have to break down this problem into a couple different right triangles. Let's start with the first sentence. Draw a right triangle that goes along with that picture, with that sentence. All right, what you should have drawn is a vertical cliff and the base of the cliff is the bottom of the cliff. And here's the top. And it says that there is a rescue team that's standing 1,000 feet away from the base of the cliff. So right there is where the rescue team is standing. And they're looking up at the climber and they're looking up at the cliff. So first of all, let's draw in the angle of elevation that's looking to the top. The angle of elevation in this question, the first sentence, is 70 degrees. From that picture alone, we can figure out how far the entire, how long the entire cliff is from top to bottom. And we're going to use SOHCAH or TOA to do that. Let's figure out which of those three we're going to use, SOHCAH or TOA. The side that we are looking for is on the opposite side of the picture. So the opposite side is what we're looking for, and the adjacent side is the side that we're given. So we're going to use tangent to figure out x. So the tangent of 70 degrees is equal to the opposite side, x, over the adjacent side, 1,000. We can solve this question very quickly by just cross-multiplying 1,000 times the tangent of 70 degrees. If I type that into the calculator, I've got the answer for how tall the cliff actually is. The entire cliff is about 2,747.477 feet tall. Now we can go on to the second sentence. The second sentence, it says that there's a climber actually on the cliff. So we'll put a C there for climber right there. The climber's on the cliff, and when the team is looking up at the climber, it's not as big. The angle is not as big as it was before. They don't have to look up as much. They only have to look up at an angle of elevation of 64 degrees. If I'm using this triangle here with a 64 degree angle, I can figure out how far that green distance is from the base to where the climber is. So I've already called this x. Since I've used x for the entire distance, I'll call this part y in green. And we can figure that out by using SOHCAH or TOA. In this particular question, it's exactly the same as the calculation we just did, except a different degree. We're still looking for an opposite side, and the adjacent side is still 1,000. So it's exactly the same, except for a different angle measurement. So I can cross multiply to find out that that green distance, y, is about 2,050.304 feet. So how far did the climber actually climb to get from where they're at to the very top? I know how long it took. It took them 1 hour to do that distance in black. So how do I figure out the distance in black? If I know that the entire height is 2747, and I know that so far they've done 2,050 feet, I just have to subtract to find out that distance in black. So subtract these two from each other, and you end up getting approximately 697 feet. And I'm going to divide that by 60 to find out that they are climbing at a rate that is about, I'll round it to the nearest whole number, about 12 feet per minute. Alright, so looking back at this question, it just involves two right triangles, and the setup or the picture is probably harder to do, in my opinion, than actually solving the equations. Once you have the good picture set up, it's just breaking out your rules for SOCA or TOA. Alright, in these last three questions, I'm going to preview the questions that we're going to be doing in class in the near future. Looking at this question here, you can see it's a lot less complicated than the last one. Once you pause the video and give it a good read. Now that you've read the video, we only need one triangle to figure this problem out. And I like to draw the picture as accurately as possible. The person's shadow is longer than they are tall. So the shadow's all stretched out on the ground. And by drawing a nice accurate picture like that, our answers should look better when we're finally done. So the person is smaller than their shadow. The tip of the head and the tip of the shadow actually make a right triangle because the person is standing straight and tall. Something that you're going to have to deal with in this question that a lot of students will fumble with is you're going to have to turn these measurements into just feet or just inches. The big mistake that students will make is they'll say that 8 feet 6 inches is 8.6 feet. That is not true. 6 inches is not 0.6 feet. 6 inches is a half a foot. So you could either turn that measurement into 8.5 feet, or you could turn it into inches total. With this question, you have a blend of measurements, 8 feet and 6 inches. Okay, that's confusing. So my recommendation is to turn it into feet, or turn this entire thing into inches. 8 feet is 8 times 12 ends up being 96 inches. 96 inches and 6 inches is 102 inches. Once that gets done, you can use that information to figure out the angle of elevation. Alright, this third question right off the bat can be very intimidating, and I wanted to give you a chance to read it. Hopefully the video quality is good enough where you can read it, so pause, give it a read, and then we'll talk about it. Alright, so what makes this question complicated obviously is that there's no picture of any right triangle right off the bat, and it also has a lot of information in the question. Some of the question information is actually repeated down below here, but there are a few things in particular that are mentioned in the question above but are not mentioned in the map below. So you want to take your time and identify all the information as much as possible, and then you're going to go on to draw some right triangles here. It involves drawing a couple right triangles, and you're going to have to be patient with taking your time with a question like this, but also have the confidence to think that, hey, I can actually do this, or at least I can get started on it and get some good, rack up some good partial credit. On this last question, what I'd like you to do is give it a good read. Look at the picture and then read it one more time. So by now you've paused the video and you've read over the question completely from start to finish. What's nice about this is that there is a picture. What's not so nice is there's a few things that can throw you. One small thing is that it's not drawn to scale. That means that any answer you come up with might not look exactly right in the picture. When they're drawn to scale, if something looks wrong, it's probably wrong. But in this question, there's no guarantees. So we've got no way visually to prove, based on this picture, if our answers are correct. The one thing about this picture that's throwing me off just a little bit is that there aren't any right triangles actually drawn in the picture. You can't use SOCA or TOA until you have right triangles in the picture. So as a suggestion, you can actually draw in the right triangle like that, which can help get things started. The tip of the canoe is 1.5 feet off the surface of the water. You're going to have to take that into consideration when you're labeling this side here in blue. Alright, and finally, one thing that makes this question a little more complicated again is that we're dealing with angle of depressions. And angle of depressions are equal to angle of elevations. Angle of depressions usually are outside the triangle. So that angle of depression of 6 degrees here is the same as the angle of elevation looking up to the top of the lighthouse here. So you're going to have to use that sort of thinking to also help with this question. Alright, hopefully this was a very successful little lesson for you, and like I said, we're going to go through these questions again in class, and giving you a head start is the purpose of this video. So good luck, and I'm glad you watched it. Keep on using the website and the videos to help you along, and work really hard to make this a successful year.